Hi, everyone. My name is Mark Mandel. I do developer advocacy. I do developer advocacy for games at Cloud, so I do a lot of infrastructure stuff for games. I'm also the founder of the Agones project we're talking about today, and I lead the open source side of Google's contributions to the project. I usually give this talk at game development conferences, so this is a bit fun and interesting. So who here works in the games industry? Whoa, OK, so that was a lot more than I expected. That's awesome. Who here are just like, this seems like a really interesting extension of Kubernetes? That's also really totally cool. I expected more of that, which is totally fine. Who's here because they just like Mark talks about this a lot and I'm friends with him? Yes, some people. OK, cool, that's fine too. All right, awesome. All right, cool. So we're going to have some fun and we'll see some cool stuff and we'll talk about game servers and Agones and that kind of stuff. So I want to sort of set the tone for some people who may not be as familiar. When we say multiplayer games, that can mean a whole lot of things. It's a wide and varied sort of thing. And when we're talking about multiplayer games, in this particular instance, what I want to talk about is very fast-paced, competitive, action multiplayer games, right? So we're talking about like your Fortnights, your Overwatches, your Rocket Leagues, things where latency really matters. Just saw some people in the back. Latency really matters. Competitive, fast-paced action gameplay is really important. And there are a variety of ways we can set this up. I'm going to use an example here. This is an open source game called Synotic. Has anyone played Synotic? Sweet. That's actually more than I usually get. Fantastic. And what we're going to talk about is actually a model for doing this, which is what is commonly referred to as dedicated game servers. And there are a few different ways we can do this, but for the matter of time, I just want to focus on this. And this has kind of become, I feel like, the prevalent way of doing big-scale multiplayer games, especially in sort of a AAA audience. So the idea of a dedicated game server is basically you have your full simulation of your game inside basically a software process that runs on the cloud somewhere or somewhere on the internet. And you have a series of players that connect to that game. Usually they send things like, hey, I want to move forward, or I want to fire a rocket, or rocket my car, or anything along those sort of lines. And it's that dedicated game server's job to be like, yes, this is the thing you should be doing. You're not cheating, that's bad. But also be able to send back to all the people playing the game, hey, this is a thing that happened. You should be aware of it, and so you can see it now. There are a couple of very good reasons for doing it this way. One of which, having control over the box that actually is authoritative and has the simulation and does all the processing in memory is kind of important because people cheat and they're mean and horrible. And so having control over that mitigates some of that. The other side of this is these sort of games are very latency sensitive. 10 milliseconds, 20 milliseconds, 30 milliseconds either way can mean a big difference in player experience and can mean that people won't come back and play your game because it kind of just sucks. So having dedicated game servers means that you have a lot of control. You can place dedicated game servers in particular geographic locations, and depending on where you put it in that geographic locations, gives you some control over the sort of latency that your players are going to play. So if we were all playing a game, for example, we would probably want a server to be here in Seattle. But maybe if I was playing a game with, say, a friend in New York or something like that, maybe we'd want to put that in central US. So it gives us some control and gives us some things we can do. So that's a dedicated game server, right? Super high level. So what does the traditional architecture for this look like? And it looks kind of like this. Some of you might be familiar with this, right? So you've ever played an online game. You have a couple of people who are like, I would like to play a game. That seems like a fun thing to do. They usually connect to some kind of matchmaker. Matchmaker's job is to group people together, usually based on skill level, maybe their social graph, things like that. And then usually they talk to some kind of dedicated game server manager. And it's the job of the dedicated game server manager to look at a large pool of machines, go hunt through them, see if they have resources like CPU and memory, start up a process for that game server, allocate a port for it. Some of this might sound familiar. Basically spin up one of these instances of a game server, put all the assets in it, all that kind of stuff, and then eventually get back an IP import, right? We want to actually make a direct connection here. So what's going to happen then is it's going to grab an IP import of this dedicated game server, and it's going to send that information back to those players so they can make a direct connection to the game. Usually this is a UDP stream, but I digress. So once we have one of these game servers, awesome. That's like it, and then players can play the game. They're both on the same machine because then they can share memory state, and that's all good. So the part we want to talk about today when we're talking about Agones is this part here, right? This server manager that manages processes over a huge number of machines. Does that sound familiar at all? We're at a Kubernetes conference. Cool. All right, I think you might know where I'm going. All right, sweet. So I was doing a lot of work in the games industry, and kind of realized that this was a problem that a lot of people had, and I didn't seem to find an open source solution for running sort of dedicated game servers. So we came up with one. So this project has been going for about a year. It's still technically in alpha. It's 0.6. We do releases every 6 weeks. But it's getting quite full-fledged, and we have people who are using it now for games. We've got one that's come out that's got live traffic on it now. We've got a couple more coming out early next year, and we're working on it pretty heavily. But basically, yeah, it's an open source platform for dedicating, hosting, and scaling game servers on top of Kubernetes. So it's an operator, much like anything else, and we'll have a look kind of how it works. But what has been super neat about this is we didn't start this by ourselves. I have some wonderful friends over at Ubisoft. Are any of them in the audience? Well, they're not that wonderful friends. No, they are wonderful friends. I disagree. No, they're just not here today. But we have some wonderful friends at Ubisoft that we've been building this in collaboration with them. That's been really great. So we can bring our experience with Kubernetes, sweet, and they can bring their experience of running really large-scale multiplayer games. But since then, we've also had contributions from about 25 different people from a variety of backgrounds. So it's been really good to get that diverse set of skill set and experience coming through, which has been sweet. All right, so let's actually look at how this thing works, and you can see how the cool things happen. Unsurprisingly, we put game servers in containers. OK, that's not like interesting. We all do that. The only fun thing about this is we do have an SDK integration. It's gRPC-based, which is kind of neat. Right now, we have SDKs for C++ and Go, and one with Rust that mostly works. And we also expose things via REST. Short answer, if you want to integrate a game server with our system, you can find a way of doing it, which is good. The functionality of this is really kind of game server specific in some ways, although may be applicable to other areas, but we're focused on game servers. So things like, hey, I'm ready. I'd like to be able to take players now. Hey, I'm done. Shut me down. I'm done. Hey, I'm healthy. Just making sure I'm regularly healthy. There's some stuff about health state that's kind of interesting. Being able to get configuration information and now get some that kind of stuff and setting configurations and whatnot. I'll talk a little bit about this too, because I didn't mention it before. Health status, you might look at that and be like, but what about Kubernetes health checking? Like, that's already a solved problem. Game servers are kind of special in that they do this migration from stateless to stateful. So when you have a game server that's running and no players are playing on it, nobody cares if you shut it down. As soon as you have players playing on it, you do not want to shut it down. Players get mad when you shut off their game in the middle of their game. Who knows why? I don't understand. And it's not like game players have any issues with toxicity at all. Like, that's not the thing. So yeah, generally a lot of the stuff inside Agones is really just making sure that game servers don't get shut down and people get mad. Cool, so we have this SDK, so it does some neat stuff around that and manages health checking in some interesting and special ways. But essentially we have CRDs, which are pretty great. So at the core level, like the base building block is we have this thing called, unsurprisingly, a game server. Woot. It looks a lot like a lot of other CRDs. We have a name, cool. But one of the things it will do for you is dynamic port allocation. So we use Kubernetes host ports to expose game servers. And one of the things that Agones does is it exposes it dynamically. So you can basically say, when you set it up, this is the range of ports I would like to expose, and it will assign one to you and make sure it's open, and then it'll give it to you at the end, which we'll have a look at in a minute. From there, we specify what container we want to have as a game server. Nothing too special there. This is a full pod spec. You can have multiple containers. You can do volume mounts, all the other usual stuff. So you can do whatever you like there. Really, at the moment, that's the default. So if there's only one container, we're like, that's the game server container. We'll expose that. Awesome. If there's more, you can just specify it. It's pretty straightforward. So that's a game server. But that's not that interesting. Much in the same way as we're all familiar with pods. Pods are great, except without deployments, things aren't perfect. So unsurprisingly, we have this thing called a fleet. And a fleet is a big group of game servers. That's really it. So much like you would have a deployment, we have a set of game servers, and we can specify how many replicas we want. And we can scale this up and down and do all the usual sort of stuff from there. And from there, under that, just sits our game server configuration. So again, if you're familiar with pods and deployments, this all should look pretty familiar. But you may have noticed that we were talking earlier about like how we make direct connections. Right? We don't use load balancers when we talk to game servers. They add extra latency. Trying to route it to a very specific machine can get tricky. Like, it's not ideal, really. And usually you're sending UDP packets too, which is all sorts of other sorts of pain. And so we want to make a direct connection. So if we're doing that, how do we like scale this out across all our game servers? Short answer is what we actually have is what we call an allocation. So basically, you need an atomic way of saying, hey, I've got this big pool of game servers, please give me one. And here we can actually say, cool, what I want you to do is create a fleet allocation. Again, it's another COD. We give it a name, and we tell it what fleet it is we want to pull stuff out of. And then it's going to create that atomically, and then when you return this, and we'll see it in a minute, it'll give us some game server state. We're actually working on a selector-based version of this that'll actually be really cool, and I'm actually really excited about it, so it's fun. All right. Let's actually show some stuff actually working. And then maybe it'll break and you'll laugh, which would be good. So for the sake of time, I've already installed Agones. It's a Helm chart. Ta-da. Can everyone see that OK? Awesome. Perfect. Awesome. Cool. So I've got that installed. So what I'm going to do is create a fleet. That's there. Perfect. All right. So kubectl apply-f examples synodic fleet.yaml. Yay, I have a fleet. All right, cool. So I can now, I love this about CRDs is I can now say get game servers. Now I can see I have 2 game servers. My fleet had 2 in it. If I want to get a little fancy with my kubectl commands, which I can do here, I can make it look like that, which is much nicer to look at. I'm just running this minikube locally, primarily because I know conference Wi-Fi is awful. So I have 2. And I can do all the kind of standard things too. I can say kubectl edit my fleet. Scroll down. I would like 5 replicas, please. Yes. Oops. Boom. So if I do this again, we can start to see that we get some more. Nothing special here, right? This all kind of looks like deployment stuff. Nothing very incredible. Sweet, they're all up and ready. That's lovely. So they're all ready. They've got player connections. The SDK's worked. They've all been assigned ports. Sweet. So now we want to allocate, right? I want to be able to grab one of those atomically out of that. So let's do a create F. Now this is usually something you would probably do through the Kubernetes API itself rather than through command line, but this is just easier. Fleet allocation, and spit us back the result. So it's going to actually go in and create some stuff, and it's going to apply some things. So we're going to run that, and we're going to get a bunch of stuff back. I'm going to make that look a little prettier and just run this again. So now we can see we have one of these as an allocated state. So remember I was talking about earlier, right, that game servers go from stateless to stateful. Allocated is the marker that says there are players on this thing. And this is important because it means if we want to update this fleet, or we want to scale this fleet, or we basically want to do anything to this fleet, those allocated game servers are sacrosanct, right? Like, you do not touch them. Players get mad, and they post things on Reddit, and then it's all very bad. So we can sort of play with this a little. Actually, let's not do that. We'll play with it in a minute. Actually, I lie. So let's actually, let's get some more. Here you can see, OK, so actually what happens when we do our allocation, there's a bunch of stuff here. We actually get back the full game server. But the most important bit is the bit here down the bottom. You can see we get an address. We get a port. We can actually assign multiple ports if we want. So let's do, like, I don't know, 3 of them. So boop, boop, boop. So we have 3 that are allocated. So if I actually say kubectl edit my fleet, and if my scrolls down, let's make that like replicas 2, for example. If we actually have a look at our pods, we should see that they're still running, right? There's still 3 of them there. And eventually we'll end up with, like, one of them's gone to unhealthy, right? And so those allocated ones never get touched because we have players on them, and then we're waiting for them to shut down. So let's actually do the cool thing and fire up a game. Because that's what you're all here for, right? Oh, this is always a fun game, which is trying to get the thing at the top. There we go. So I can see it. All right, perfect. So I can actually prove to you that we can play a game, assuming I can type correctly in front of a room of people. 122, 187, colon, which one we got? 7102? Perfect. So let's join that game. So black screen is good for whatever reasons, because whenever I do demos, it just likes to give me a heart attack. So wait for that to load. Awesome. So actually, yeah, so right now on my trackpad, and I'm not going to say that I'm any good at this, I'm playing against a bunch of bots, and this is running on my Kubernetes cluster. So this could be running anywhere. It doesn't matter if it's on my Minikube cluster. It doesn't matter whether I'm running on GKE or any other cloud provider. It's all good. You can actually play a game, and it's kind of neat. All right, let's talk about some other stuff. Awesome. So we'll talk a little bit more. So from the architecture that we were talking about previously, now rather than like connecting to this custom server manager, our custom matchmaker, and we have an open source one of those too, it's called Openmatch if you're at all interested. Strangely enough, it runs on Kubernetes. It can talk directly to the Kubernetes API and talk directly to the resources and the CRDs and like basically use all the same things that you would be familiar with when dealing with Kubernetes resources, which is really cool. So it can then be like, hey, from that fleet, can I have a game server? And it can be like, yeah, I've got plenty. It's totally cool. Here's one. Grab the IP import, much like it did before, and push it across, which is like any extension to Kubernetes, just kind of really cool, because then all the Kubernetes stuff all works the same way, which is pretty sweet. We have a whole host of other features as well. I kind of want to highlight the fact that this is all just vanilla Kubernetes, so it works across cloud providers. If you want to run it on-prem, anything that supports a host port for network topologies, you're good to go. We've got people running it across both, which is also really sweet. We have a whole host of fleet and node autoscaling. So we've got a bit of time, I'll talk about that a bit. So we've got some basic strategies for fleet autoscaling within a cluster that'll get expanded out, but we've also got it integrated now with the Kubernetes cluster autoscaler. And that's actually got some really nice hooks into it as well, so that you can actually mark which pods don't kill these nodes that have players on them. And that works really well. We have some scheduling strategies for that to make sure everything gets packed really nicely, so that works really well as well. We've got we've got some local development tools as well, so if you're working locally, or you're probably working on Windows if you're working in the games environment, so you don't have to spin up a whole Minikube environment. You can just see what's happening with that SDK tooling that you integrate with your game server as well. And we have a whole roadmap on top of that as well. So all sorts of other fun stuff coming. So we want to expand on fleet autoscaling. We want fleet autoscaling to be the basic building block of our autoscaling kind of thing. We want you want to expand your fleet, and then your cluster adjusts, very much like you would do normally inside Kubernetes. So we've got some fun stuff coming there. Statistic collection and display. So we want to have really standard statistics around like how many game servers you're running, what's your scale like, what does it look like, all that kind of stuff. But we also want to do very specific game server specific kind of statistics too. We want to make that easy. Things like knowing your CPU tick rate, right? That's really important for game servers because that dictates like how fast your simulation can go, and if you have hitching in your CPU profile, that's a bad experience for your players. But these are the sort of like statistics that we all need as building game servers. Right now, we don't have great commercial engine integration, so if you're using like Unity or Unreal, we want to have some out-of-the-box stuff. People are already doing it just using the REST API, and that works great. It's no problem. Windows hosting, anyone from Microsoft here? Oh, I was gonna be like, please work on this some more. It's really great that you're doing that work. And thank you very much for all the effort you've put in. Oh, well, it'll be in the recording, but yes, thank you. Basically, we're waiting on that to come through, and it looks like that's moving at a really rapid pace, and I'm really excited about it. For those of you who don't work in games industry, everyone uses Windows. That can be a bit surprising for people who don't work in the games industry. So even though things might necessarily get hosted on Linux, and there's definitely production Windows use cases, the development environments for most game developers is Windows. So having a short iteration loop for Windows developers is really, really important for us as well. So anything we do, make that shorter. Multi-cluster is also really fun, and one of the reasons I'm at KubeCon. So we're looking at how do we set up and orchestrate fleets across multiple clusters and allocate across multiple clusters. And I have some really cool ideas from some of the talks I've been to today, which has been really good. But we actually have tools coming in the next release for just standard things you need for game servers, like what's my round trip time, right? What's my ping time between these different regions and that kind of stuff. So we just, again, this is all like plumbing stuff that just various people need. So we've got 5 minutes for questions at the end, which is great. I didn't mention at the beginning, but I've also left a pile of my business cards and some stickers down here in the corner. So if you think, oh, I might have questions later, please come up and grab some. But before we get stuck into questions, agones.dev redirects to the GitHub repo, so you can check that out, and you can check it out on Twitter. You can also reach out to me on Twitter, and I Twitch stream Agones development pretty regularly. So if you want to see more about how controllers work and how to test them and things like that, you might find that interesting. And I'm wearing this t-shirt that says the Google Cloud Platform Podcast. So I feel like if I didn't mention it, that would be sad. But we talk about all sorts of stuff, from game stuff to cloud stuff to Kubernetes stuff to machine learning and all sorts of other things in between. Awesome. We have 5 minutes left. Excellent. That was really fast.
You mentioned the commercial game engine integration.
Yep.
Do you have, are you working with Unity or Unreal on those integrations, or are
We're looking at the community. Honestly, the SDK is really simple. Like, it's like we have like 5 API calls. It's like, hey, I'm ready, hey, I'm not. Let me know when a configuration changes. I would like to put a label of, like, with this prefix on my things, and like, that's about it.
The reason I was asking is I know Unity is kind of partnered with Google, so the next iteration of Unity's networking engine is pretty much targeted at making this type of work, specifically in the fast-paced games.
Yep.
Across the board.
Yep, so the question was, just to reiterate your question, we were talking about whether we're working with either Unreal or Unity. So yes, we do have the strategic alliance with Unity. The thing with this project is we are about hosting and scaling. We don't care about communication protocols. So if you want to use WebSockets or UDP packets or HTTP connections, I do not care. As long as you've got a thing that does in-memory simulation, it's a good platform for you. So, in the back. Whoa, how do we deal with noisy neighbor issues? Generally, I push that down into the providers, is the short answer. The things we've been seeing is usually that tends to become, so the issue is like, how do we deal with noisy neighbors? And we were talking previously, for people who aren't familiar with game servers, CPU click-through rate and keeping that stable is really, 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 really important. Usually that really comes down to the underlying VM infrastructure more than anything else. We do advocate that people set CPU limits or requests and test that accordingly inside their clusters, and that's also a nice way of doing it. So if you set pod level CPU limits or requests, then that actually impacts the scheduler as well. So then you can actually be like, okay, this one needs a whole CPU because it has a lot of players on it, and that means then we can only fit 4 of them on a machine because there's probably like 4 or 5 or 6 cores on it, and then that'll impact scheduling and that kind of stuff. Does that? So again, that comes down to load testing and like how your cloud provider and the network that gives you and that kind of stuff, and so we kind of offshoot to them and how they do that. It depends on your cloud provider and how much network bandwidth you have and how much that impacts things inside that VM, and then like what size do you use, and then all that kind of fun stuff. So the question around network bandwidth. Over there.
So a lot of this is around hearing like massive multiplayer, like low latency kind of games. What about transactional games like close the board with grids? Is there application for that?
Not probably. So the question is like transactional games. You can probably get away with a lot of just RPC type services for things like that. And so I would just use regular web tech, and it's probably fine. Things like WebSockets, gRPC can also help, that kind of stuff. There was a question over on the far right I did see.
Does a single dedicated server serve the global needs?
So in theory, it could. Under this model on Kubernetes, I would very much advise against it. I really like the Kubernetes container model, which is you have a container and like everyone connects to that, and then once it's done, it shuts down and goes away. I've definitely seen people who have processes and it supports multiple games. I think it's much cleaner to work it this way and a little less risky. Over there.
How do you handle node maintenance?
Oh. That's a really good question. How do you handle node maintenance? So mostly what I actually tell people to do is use node selectors or node tents to handle it. So if you've got a game that cycles through, you could spin up a new node pool of the new type you want, and then specify and then change your configuration basically to spin it up so that you could actually do a rolling update with the fleet with the new node selector or taint, depending on which way you want to do it. So it all goes into the new node pool. Wait for all the game servers to disappear, and then you can kill the other node pool, and you can just switch. That's the way we've been talking about doing it. Yeah, because people have run into that too. That's a fun problem. But because we have the node selectors and node taints, that actually isn't too bad. It was in the middle. I'm kind of going backwards and forwards. Yeah. Yeah, so that's what we do. So at the end of a game server, you shut it down, and so but you have to wait for the allocated ones to disappear. Yeah. So yeah, that's a good question. So how does the container port get exposed? So what we do when you set up a game server, it fires up a pod, and it exposes that as a host port, so that we have basically network isolation between each of the game servers. So right now that routes through IP tables, adds about 0.5 milliseconds of latency. that's time. It adds about 0.5 milliseconds of latency, but there's some new stuff coming that'll be even faster, and that's like worst case scenario. And so we've been pretty happy with that. All right, I need to go. I'll be hanging around, so if you have more questions, please feel free to grab a card. Thank you so much for hanging out with me today and talking about game servers.